Good morning, sir. Today we will present our analysis on the correlation between premium growth and profitability in the Sri Lankan insurance sector. First, let's look at our statistical tool. Correlation is a method used to find the relationship between two quantitative variables. As shown in the graph, it measures both the strength and direction of a linear relationship ranging from -1 to +1. Crucially, we must remember that correlation implies association, not causation. It tells us if variables move together but not while. It is vital to distinguish correlation from regression as written in our lecture notes. While both techniques technically measure a relationship, but they serve different purposes. So we highlight the mandatory differences. The first one is regarding variables. Correlation is limited. It handles only one variable against one variable. But regression is more powerful. It can handle many independent variables impacting one dependent variable simultaneously. So this is the key difference. The second one is regarding prediction. Correlation cannot be used for prediction, but regression is specifically designed for prediction. It is estimating the line equation to forecast future values. The third one is regarding direction. As shown in the diagram, correlation is symmetrical, while regression is directional. Therefore, we strictly use correlation because we are analyzing a simple one-to-one association. Before applying this test, we ensured three key preconditions were met. The first one is quantitative data. Both our variables are numerical. The second one is linearity. We check that the relationship follows a general straight line. Third one is absence of outliers. As illustrated in the chart, we identified and handled outliers to prevent false results.
Correlation is applicable whenever we need to assess the strength of an association between measurable factors. General example, in biometrics, for instance, we often see a positive linear relationship between height and weight. Finance example. However, for our field, the most classic application in the trade-off between risk and return. Investors use correlation to determine if taking higher risk is statistically associated with receiving higher potential returns. For our case study, we selected 11 listed insurance companies and identified two key variables. First, for variable X, we chose premium growth. This measures the company's business expansion. Second, for variable Y, we chose return on equity. This measures shareholder profitability. As mentioned in the blue box below, we purposely selected variables from different financial statements, revenue versus equity. This ensures they are structurally distinct, allowing us to avoid spurious correlation and strictly test if top-line growth actually drives bottom-line efficiency. Based on our objective, we formulated the following research hypothesis. First, the null hypothesis. We state that rho equals 0. This implies that there is no statistical relationship between premium growth and return on equity. Second, the alternative hypothesis. We state that rho is not equal to 0. This implies that there is a statistically significant relationship between the two variables. Our goal in this test is to see if there is enough evidence to reject the null hypothesis.
Okay, now I'm going to explain how do I do the calculation in Excel sheet. So to calculate, to first of all to calculate calculations, we should find the total value of this x variable and y variable. To calculate total values of this x variable and y variable, we can use sum function. It is easy to calculate total values and select the cell range and close the parentheses. You can copy this function using fill handle. It is easy to calculate. Next step is calculate mean value. Uh, to calculate mean value, we can use average function. It is easy way. Type average and choose average function name. Select the cell range and close the parentheses. You can get the mean of x. Same as you can copy this function by using fill handle, and you can get mean of y. Then you can calculate x minus x bar square equal sign open parenthesis x minus mean of x. You should keep on mind using dollar sign before the serial number of mean, because this mean of x is constraint, and close the parenthesis and square. Press enter. Then you can fill these cells using fill handle. In the same manner, you can calculate y minus y bar square open parenthesis y minus mean of y. Keep in mind, use dollar sign before the serial number of mean of y, and close the parenthesis square. Press enter, and you copy this function using fill handle. Then you can calculate cross production equal sign open parenthesis x minus mean of x. Use dollar sign and close the parenthesis multiplier, open another parenthesis y minus mean of y. Use dollar sign and close the parenthesis, enter. You can get cross production value. Copy using this function by fill handle. Next, you should get all total values by using field handle. That's it. Then you can label these functions. It is easy to identify. I use green color for total values, and I use yellow color for mean values. Then you can, next step is calculate degrees of freedom. Equal, we choose as 11 companies, so 11 minus 1. Our degrees of freedom is 10, and copy using fill handle. So next step is calculate variance. uh, Variance, we can calculate equal sign sum of x minus x bar square divided by degrees of freedom. In the same manner, you can calculate variance of y, sum of x minus y minus y bar square divided by degrees of freedom. You can get variance. We can apply color for this blue color for variance. Okay. Next step is calculate standard deviation. Standard deviation equal sign. We can calculate in standard deviation in Excel. There is easiest way. STD, standard deviation of sample. Then select the cell range. Close the parentheses. You can get standard deviation of x. In the same manner, you can calculate standard deviation of y. STD, standard deviation of sample, and select the cell range. Close the parentheses. You can get standard deviation of y, and you can label it Okay. Next step is calculate covariance. Covariance can be calculated using equal sign, sum of cross production divided by degrees of freedom. You can get covariance as 110. Next step is calculate correlation. To calculate correlation, we can covariance divided by sum of standard deviation of x and y. You can get correlation. There's an alternative method calculate correlation in Excel. There's a shortcut way equal sign correlation and select the variable and y variable and close the parentheses. You can get same correlation value through. This is easiest way. So we can label it also. Next step is calculate t value. To calculate t value, correlation into square root of, so we selected 11 companies minus 2 divided by mm, open another parenthesis 1 minus into correlation power 2 thin close parenthesis. You can get t value as 2.711. So our critical t value is 2.6262. So our calculated t value is greater than critical t. So we can reject our null hypothesis and accept the alternative hypothesis. We can calculate t value using uh, t statistics table. So this t value shows the correlation is statistically significant.
We start by opening the Variable View tab. In the first row, we name our variable GWPG. For the label, we type Gross Written Premium Growth. We set a measure to scale. In the second row, we name the variable ROE. For the label, we type Return on Equity. Again, we set the measure to scale. Now we switch to the data view. We open our Excel sheet to get the data. We select the percentage value for all 11 companies, copy them and paste them directly into SPSS. To run the test, we go to Analyze, select Correlate and choose Bivariate. We select both variables and move them into variable box on the right. We ensure Pearson is selected and two-tail is used. Now we click option to display descriptive statistic. We tick mean and standard deviation, then tick cross product deviation and covariance, then click continue. Next we click confidence interval option and tick estimate confidence interval and ensure 95% level and click continue. Finally we click OK. The result is appear. First, the descriptive statistic table shows the mean and standard deviation for each variable. Here, gross written premium growth has a mean of about 13.76 and return on equity has a mean of about 14.09 based on 11 companies. Next, the correlation table shows the Pearson correlation value. The correlation between premium growth and ROE is 0.671, which means there is a positive relationship. The significance value is 0.024, which is less than 0.05. So this relationship is statistically significant. Finally, the confidence interval table gives the 95% confidence interval for the correlation. The range is from 0.1182 to 0.906, which also support that the correlation is positive. So overall, SPSS confirm a significant positive relationship between premium growth and ROE. Now let's create the visual graph. We click on graphs, go to legacy dialog and select scatter dot. We choose simple scatter and click define. We drag return on equity to the y-axis. We drag premium growth to the x-axis. We click OK. The scatter plot is generated. The dot show an upward trend which support a positive relationship.
Before we state our finance formal interpretation, we validated our hypothesis using two distinct statistical methods to ensure our decision is robust. First, we used the t-statistic method. We compared our calculated t-statistic of 2.714 against the critical table value of 2.262. Since our calculated value is greater than the critical value, the relationship is deemed significant. Second, we used the p-value method. Looking at our SPSS output, we obtained p-value of 0.024. Since this is lower than the standard significance level of 0.05, this confirms our findings. As you can see, both methods lead us to the exact same decision. The result is significant. Based on these results, we can make the following statistical interpretation. First, regarding significance. The correlation coefficient of 0.671 was found to be statistically significant at the 5% level. This is because our p-value is 0.024, which is less than the standard alpha value 0.05. Second, regarding the hypothesis. Based on the significance level, the null hypothesis is formally rejected. We reject the claim that there is no relationship between the variables. Third, regarding the association. We conclude that there is a significant positive association between premium growth and return on equity. As shown in the graph on the right, as growth increases, profitability also increases. To conclude our presentation, we have summarized our findings into three key takeaways. First, our statistical finding. We found strong evidence, especially p-value less than 0.05, to support the relationship between company growth and profitability. Second, the business insight. Our analysis proves the issuers who aggressively expand their gross written premiums or market share tend to generate significantly higher return on equity for the shareholders. Finally, our final verdict. The data supports the economies of scale argument in the Sri Lankan insurance sector. It suggests that as these companies grow larger, they drive better efficiency and returns. That concludes our presentation. Thank you for listening, sir.